This is the second presentation in the series on lenses. It is on the cardinal points. Lenses are of many varieties. They can be biconcave, biconvex, planoconcave, planoconvex, shallow meniscus, or deep meniscus. The center of curvature of the surface of the lens, it is the center of a sphere of which that surface of the lens forms a part. The radius of the sphere is called the radius of curvature. Optical axis is an imaginary line connecting the centers of curvature of the two surfaces of the lens. Here are examples of different lens forms showing the center of curvature and the radius of curvature. This is an example of shallow meniscus lens. This is the center of curvature of the anterior surface, and this is the center of curvature of the posterior surface. Parallel rays falling perpendicular upon a convex lens are rendered convergent. There is one small element in the center of the lens that acts like a parallel plate. A central ray passing through center of the lens is not refracted and emerges undeviated. This is known as the primary ray. So the primary ray will pass along the principal axis and hence pass through the optical center of the lens, which is located along the principal axis. If a beam of light strikes the lens not in a perpendicular but in oblique way, there is again one central ray which again emerges parallel to the original direction. This is known as the secondary ray. If the lens is very thin, this slight refraction may be neglected and the ray may come out continuous at the incident path. We usually place objects on the left side and draw rays to form an image on the right side. So this is the image space and this is the object space. There are 6 cardinal points that can describe any optical system or thick lenses. These are essential to know. Once defined, all is known about the optical system or the thick lens. These points are F1, F2, P1, P2, and N1, N2. Parallel rays falling on front surface of the lens will come to a focus on the other side called F posterior or F2. If parallel rays fall on the back surface of the lens, they will come out from the front surface to converge to F1 or F anterior focal point. So this is F1 and F2. When parallel rays from a distant location are rejoined to form an image, this will be located at F2. F2 is located in the image space. On the other hand, F1, it is the point in the object space from which light must originate to emerge parallel from the lens. So, where is F2 in case of concave lens? Parallel rays falling on a concave lens will diverge. If an eye receives these rays, they will be traced back to originate from F2. So in case of concave lens, F2 is located on the left side of the lens. So notice that F1, F2 in case of concave lens are located opposite to those of convex lenses. The vertices V and V dash are the points of intersection of the axis with the lens surface. If parallel ray gets into a lens, it will come out to pass in F2. If we extend the incident ray forward and the emergent ray backwards, they will meet at the anterior principal plane. Again, if parallel ray hits the posterior surface, it will come out to pass through F1. If we extend these rays, they will meet at the posterior principal plane. In thick lenses, we have two principal planes, but in a very thin lens, we can have only one principal plane. In general, the principal plane P and P' do not coincide with the vertices. The anterior principal plane, or P1, is in the front surface where refraction occurs. The posterior plane, or P2, is near the back surface. If rays coming from the right side, it will hit the surface and refraction will occur. Object distance, or U, is measured along the principal axis from P to the object, and the image distance, V, is measured along the optical axis from P' to the image. As you notice here, P' is drawn outside the lens. Location of P and P' are not necessarily inside the lens. Their location depends on the shape of the lens. Most optical systems have a pair of nodal points. The nodal points are usually on the optical axis. In case of a thick lens, we have N1 and N2. From any object point, a unique ray passes through the anterior nodal point. This ray will emerge from the optical system along a line connecting the posterior nodal point with the image point. This emerging ray from N2 is parallel to the incident ray to N1. Occasionally, the nodal points overlap, as in very thin lenses, to have one optical center. Where ray passes through this point will continue undeviated. The location of the optical center N depends on the shape of the lens. Optical center is located inside the lens in case of symmetrical biconvex lenses, but in meniscus lens, it is located outside the lens. Parallel rays falling into a thick lens will be refracted at P1 and will come out from the other side to reach F2. Parallel rays hitting the back surface of the lens at P2 will come out to reach F1. Oblique ray hitting N1 will come from N2 parallel to the original path. These 6 cardinal points are essential to be known: F1, F2, P1, P2, N1, N2. These are essential to be known in any thick lens or optical system formed of group of lenses, as we are going to discuss in later videos. Thank you.